Hello everybody, we're going to be doing numbers 42 and 43 in this video, which deal with arithmetic or geometric sums. So if I took a look at number 42, I noticed that my function inside the sum is 2 times 5/2 to the n, which looks like a sub 1 times r to the n minus 1. So if I see a fraction to a power, that leads to the fact that this sequence has to be geometric because it's more exponential, which means it's usually a multiplication or division pattern in the sequence. Now, before we do this problem completely, if I was given a sum that was from n equals 0 to 10, and the function was something like 3n plus 4, this function, 3n plus 4, is linear, which means that this would have to be an arithmetic sequence. But this one has a fraction to a power, and it's increasing rapidly, so it has to be geometric. So, specifically, if I'm trying to find this sum, I'm trying to find a sum from 0 to 10. So that means this is a finite geometric sum. And instead of counting, plugging in 0 to 10, there is a formula we could use instead. The sum is really a sub 1 times 1 minus r to the n. Just the r is being raised to the n, not the whole thing. This is over 1 minus r. So, in this case, the r value, or the common ratio, is 5/2. The number of terms, which is n, if you're going from 0 to 10, so first, if you're going from 1 to 10, that would be 10 terms. But because I'm going from 0 to 10, there's actually 11 terms. And if you actually counted on your fingers and went from 0 to 10, you would count 11 things. So we would plug it in as such so far. We still need to find what a sub 1 is, but we'd have 1 minus 5/2 to the 11th power over 1 minus 5/2. But to find this first term, we are not plugging in 0. This, again, is an output value. So, to find the output value, I'm starting at n equals 0. So I would plug in 2 times 5/2 to the 0th power. So this means what is your first term of the sequence. So technically what you're really finding is a sub 0, because that's the first term. So that would be 2 times, anything to the 0th is 1, so the first term is actually 2. And so, if you plug this into your calculator, if you do 1 minus 5/2 to the 11th, multiply that by 2, and then divide by 1 minus 5/2, that's really the same thing as if you divided by, because this is really 2/2 minus 5/2, so you're really dividing by negative 3/2. If you plug this in, you're going to get quite a large answer. I got that the sum was 31,787.81. So please check that. If you do 1 minus 5/2 to the 11th first, then multiply by 2 and divide by negative 3/2, this should be your answer. So that means if I plug in the 0th term all the way to the 10th into this function and add the results, this would be my total sum. Number 43, find the sum. So first, let's decide if this is arithmetic or geometric. Because I have a first term times looks like a ratio to a power, this is geometric again. This time, though, I'm going from 1 to infinity, which means it is an infinite geometric sum. So if it's infinite, we have a different formula. We have that the sum is a sub 1 over 1 minus r, a lot simpler than number 42. I would like to point out, though, that in order to find a sum, this common ratio must be between 1 and negative 1. Let's see, is negative 3/4, which is 0.75, is that between 1 and negative 1? Yes, it is. So that means I can actually find the sum. If this is smaller than negative 1 or bigger than 1, the answer would go to infinity, so there would be no sum. But in this case, we can find it. The common ratio is 3/4, so the bottom would be 1 minus 3/4, because that's the r to a power. The first term can be found by plugging in n equals 1 into my function. And my function is 3 times 3/4 to the nth power. And so if I'd like to find a sub 1, I would do 3 times 3/4 to the first power, which is really 3 times 3/4, which is really 9/4. So I'm taking 9/4, and I am dividing that by 1 minus 3/4, which is really 4/4 minus 3/4, which is 1/4. That is the same as 9/4 multiplying by the reciprocal of 4/1. So my sum ends up being a nice answer of just 9. So this is a really good problem to do without a calculator because the reciprocal ended up making it very nice. One more thing before this video ends, please remember that when you're finding an infinite geometric series, that this R value must be between -1 and 1. One more thing, there is no such thing as an infinite arithmetic sequence, or an arithmetic sum. So that means if you see infinity on the test, it has to be geometric. Okay, so that's the end of this video. Thank you.